I clicked go live, so it says we are live. Awesome. Let me go to LinkedIn here. Make sure that I can see stuff on LinkedIn.
Hello for anybody that is watching us live. We're just getting stuff set up here.
Yeah, we're getting used to this, so we want to be able to respond to comments and whatnot. So we're just loading LinkedIn.
Yeah, so I definitely see this, and I'm going to share it as well to people. Looks like we got some visitors here. Say hi. I am live with Matt again, and we are talking COVID-19. There we go. And then I'll do hashtag.
I'm still trying to find it on LinkedIn, so let's see if I can load it here.
And we'll do. There we go. Yeah, looks like I can give this to you if you don't have a link to it, Matt. But we're definitely live on YouTube. We're live on LinkedIn, and
okay, there we go. We are live on.
As the guy from Fox News says, what's his name? We're doing it live.
I guess so.
There was a famous clip. There was a famous clip in when they went live that they kept on having technical issues, and it's a live TV show. I've actually worked in live TV, and then finally he was just like he's started screaming, and he's like, "We're doing it live!" So we're live. So
okay, we're live. I'm waiting for LinkedIn to come in, but I guess we'll get started while that page is loading. My LinkedIn is apparently having issues today, so I'll do our intro and we'll get started. Welcome to the You Ain't Gonna Need a Podcast, or YAGNI for short. This is a podcast and live stream to discuss programming, data science, cloud, and careers, and other topics that the hosts find interesting. Your hosts are Noah Gift and Matt Harrison, authors, instructors, consultants who try and distill these topics. How's it going, Noah?
Going great. I'm happy to be here and do some live stuff. I've been doing a lot of live webinars in the last few weeks here. Just did 2 yesterday with AWS on live training and asynchronous classes, and it feels like we're in the new normal now, which is everybody's on TV, except for the TV is a device in your pocket.
Awesome. How did those classes go?
Pretty good. The engagement, there was I think close to 1,000 people in the webinar I gave yesterday, and there's a lot of excitement for university instructors on how to go live or go async and do remote training and use video resources and really adapt to the new paradigm that we're in. So a lot of great engagement in the webinar that I did.
Awesome. That's so yeah, I've been busy most recently. Well, I've got there's a comment here. Someone said, I can't tell if it's Matt or Matt's teenage son. Yeah, so I guess news for me, I fell into the blender some hair recently. If you've seen me, I was a little bit more shaggy than this. So news on my end, I am working on doing a live Python and Pandas course, which will be a multi-week course, multiple hours, which will be coming up very soon. So this will be free to people who want to view it live. And so if you're interested in that, just follow me here on LinkedIn, also on Twitter. I will be talking more about that. Other than that, I've been a little hands down on my next book project. Well, trying to wrap up the second edition of the PyCharm Essentials book, and that should be getting wrapped up very quickly. And I'm also working on a new Pandas book. So Pandas 1.x cookbook came out a month or so ago, and I'm actually doing another cookbook, or not another cookbook, another Pandas book. That name is still to be determined, but I think this is going to be sort of in the same vein as my illustrated guide to Python book. It has a bunch of idiomatic Python pandas code and a bunch of, I think, great illustrations, charts that explain what's going on there. So I'm excited about that, and I'll be posting more about that as well. So, okay. Let's see what other. Ganesh said, sorry, I missed the agenda. Russell Williams says, nice to see you both. Okay, good to see you too. Yeah, Noah, what's the agenda for today?
Yeah, so today what we thought we would do was, Matt and I have some similarities in that we're both writing tons of books at the same time and do a lot of online training, like these impromptu trainings. So we figured we would do some of the things that we do in other platforms live here. And so, obviously the hot topic is COVID-19, and it's true from a boring standpoint, like you can trip and fall and hit 6 or 7 COVID-19 charts, right? Like they're everywhere. It's like the flaming Mo, if you've ever seen The Simpsons, where it's like everybody has the drink now, like it's out of the bag. But from a educational standpoint, that's a good thing, because just like Python, Python is not complicated. It's a boring old language that's been around 20 plus, what is it, almost 30 years, I think. So COVID-19, I think, is a great way to learn how to do data science. Many people are interested in data science. And in fact, hopefully even people in the government of the United States at some point will get data literacy. I think we have some severe problems there. Basically everybody should have some kind of data literacy, understand, what an exponential growth curve is, what a logarithmic curve is, and so I think COVID-19 is a good place to start in terms of like teaching people how to code in Python, how to do data science. So that was really the idea today, is let's dive into some of these charts and dive into some Jupyter notebooks and show people how to think about it and how to do data science on something that literally even your grandma, your grandpa, everybody is all interested in the same topic right now. And so this seems like a great topic to do beginning data science on.
Yeah, awesome. So I think I'll start off, and I'm going to share my screen here. And what I've got is just an empty notebook. If you've been following me on Twitter or LinkedIn, you'll know that one thing I've been doing is posting daily updates of what's going on locally here in Utah. And so I'm just going to demo how to do that on your own machine if you want to. So I'm going to walk through the plot that I'm making and sort of talk about the pandas code that's there. So my plot is pretty basic. So let me just give you the lay of the land here. In Utah, we have around 2019. And when I started doing this chart here, I think we had 10 or so cases. So I just wanted to track what was going on and see what that curve looked like. But I also wanted to, just leverage social media or whatnot to bring it to the attention. So just other people are aware of that. There wasn't, at that point in time, there wasn't, the local government had some reporting, but I wasn't really a fan of the chart. So I decided to roll my own or bike shed my own. So I'm going to just show that here. And so I've got Jupyter Notebook open, and let me come up here, and I'm going to toggle the toolbar here, and I'll bump the font a little bit just so people can see it a little bit better. So I'm going to import pandas. I'm going to insert our matplotlib inline, and I think that should be enough. If we do that, we should get going here. I might use some Seaborn later. So originally, when I was doing this, I had my own data set. What I did was I hand scraped it off of the local government. They were posting data. It wasn't available as a CSV. They're just saying that these are the daily counts here. So what I did was I just copied that and made my own CSV. In the meantime, there has since been a project on GitHub, this COVID-19 tracking. Nice little project here. It has raw state data, and so I'm just using their state data. So every day around 4 p.m., sometimes it's more around 8 p.m. my time, 4 p.m. I believe Eastern, they update that. And so I'm just leveraging that data here. I've got pandas can read a URL, and so I'm passing in the URL to this read CSV function in pandas, and I'm telling it to parse a couple dates in there. And then I just like to filter it by my date here, so, or not my date, my state, make sure that the state is Utah, and look at what that looks like. So, and back, let's see, while that's going, I've got a question here from Riyadh. Riyadh says, any recommendations for non-programming related statistics science textbooks? What's your take on that, Noah? Non-programming related books.
Yeah, so one of the things that we'll kind of go back and forth on is that I'm actually working on a book designed specifically for the non-programmer, non-stats person, just complete absolute beginner. It's this book, Minimal Python. I put a link to it, but I think that would be a good source. There's some notebooks in the reference that I put on there that will get you started. But I do think really there's a lot of upside to the non-programmer getting started with statistics and data science, and there's absolutely no reason why everybody can't get started. And you'll see from some of the training that we're doing here about really how straightforward it is to reason with things that you hear on the news. And in fact, kind of expanding on this, it's funny when you're an expert on something and then you start to see what you're an expert on broadcast all over the news, and then you realize how actually uninformative the news really is because they're just repeating what Matt's doing right now is basically doing 2 lines of code, and he's able to pull in all this really important information that is basically less less good. I'm sorry, the news organizations are less good than what Matt himself is doing. So that's really, what we're teaching you is how to actually verify yourself information, data, and actually do it yourself. And I think this is such an important skill to have. And so to your point, the link that we gave you, plus, just looking at what Matt's doing here is I think a great solution to learn this.
Yeah. And yeah, I have my book, Illustrated Guide to Python 3. I think obviously biased. That's what I have for teaching Python as well. But as far as a data science book, one data science book that I've liked that's not really, it's meant for more high-level people, and maybe if that's your question, is called Data Science for Business. I believe O'Reilly published that. Authors are Foster Provost and Tom Fawcett. I think that's a pretty good one to sort of talk about what's possible with data science and give you an idea of what you can do and can't do. I think a lot of people out there just think that, oh, I have data and I see all these amazing things going on, or I see Iron Man and Jarvis, and so I can do whatever I want with your data. Sort of gives you concrete examples of like, these are things you can do with data, and these are things that you cannot do with data. Let's see.
But yeah, this data set that you're using, Matt, here, I like that. So I believe it's the same one that I'm referencing, which is that somebody at New York Times cleaned up the data, kind of put it in a spot, and they update it like nightly, right? I think it's the same.
Yeah,
Yeah, which
yeah,
is great.
it's got daily data. It does a pretty good job. Let me just make another cell here. Um, so if I've got this DF here, and let's just look at the columns that are in here. So we've got the date, the state, the number of positive, the number of negative, the number of pending tests, hospitalized currently. And I think the hospitalized, for those who are maybe not aware of the situation, or maybe just in general hospitalized, I think a lot of the people, at least in the data community, are coming around to saying that that's actually a better number to track than the positives, just because there's no, at least locally here, they're testing like 1 to 2 to 3,000 people a day. In Utah, coming back with around a 5% positive rate. But there are a lot of people I talk to, and they're like, I think I had this a month ago, but I can't get tested, or they wouldn't let me get tested, right? And so we do know, I think it's great that most states, I believe, are reporting this hospitalized rate, which is the people that they checked into the hospital for COVID-19. And that, I think that gives you more of an apples to apples. If you are trying to do some analysis on this and you're just looking at positive rates, depending on where you are and how many people are testing, it might not be an apples to apples comparison there. Another thing to actually check as well, and then this is maybe a little bit more gory, is the death rate, right? Because you have these numbers coming out of other places that have preceded the US and have given us a clue as to what's going on. And so, this is the percent that are affected, this is the percent that get hospitalized, this is the percent that die. And those, there's some error in those, but there is a range where people believe that to be. And so if you can track the death and the hospitalization rate, it probably gives you a better understanding of what's going on than just the purely positive numbers there.
Yeah, I think that's one of the key interesting questions from a data science perspective. I mean, obviously, the two of us are not epidemiologists or doctors or whatever, but we can talk about data, right? And we can look at the numbers and interpret it. And it does seem like one of the key factors is this IFR, the infection fatality rate, right? Which is, what percentage of people were infected and then died, because that
Yeah.
really tells you the seriousness of it. And there is actually, from Lancet, published something that looks like it's something like 0.66 percentage, so like about a 0.5% or so of IFR. And then you can calculate, based on if you're exposed to it, that's, if you think about 1 in 2, that's basically 1 in 200, that's not great. That's not like, if you ask someone, hey, would you be okay with you get in the car and there's a 1 in 200 chance that you die? I think most people would not be okay with that. That is definitely a fairly significant number.
Yeah. And as of today, when we're recording this, which is April 10th, 2020, I saw a thing this morning that COVID-19 is the #1 killer in the United States right now. So more people are dying of this than anything else. Let's see. Another question here from Rob Oakes. Hey, Rob. It says, is this data from the Utah State repository or the caseloads provided from New York Times? So I believe this is transcribed from the Utah State repository, Rob. Basically, when I was tracking my own data, I pulled up this data and they kind of lined up. And so I haven't dug into it more, but I don't know where else they would be getting this data from. So hopefully it's from there. I haven't really followed that anymore. Noah, you're checking your side? Are you seeing any questions or comments on your
No,
side? If you are,
yeah,
let me go.
yeah, I'll make sure I address them if they come up.
Okay, so let me just sort of walk through some analysis here with some pandas and show making a simple plot here. So what I'm going to do is I'm going to start with this data frame here, and this data frame has all 50 states in it. So the first thing I'm going to do is I'm going to do a little filter here, and I'm going to say I want to filter where the state is equal to UT. That's for Utah here. Now, any of the 50 states, this should have data for you. So if you're following along at home or want to take this code, I'll post this code up on GitHub. I'll make a gist of this after, and anyone can take this code and you can basically make a similar plot for your state if you want to. So if I do that, and if I just run this code here from Jupyter, I get, here are all the values for Utah for the past month or so. One thing I will note is that if you're new to Python and you don't, like, I'm using Jupyter here installed locally on my machine, but if that sounds overwhelming to you, here's a power tip. You can go to Google. They have a product called Collab. It's free to use, and Collab already has all these libraries installed for you, so you can just go there and you can basically just take this code and run it there. So if the prospect of installing the code is maybe too overwhelming for you, check out that Collab project. Okay, the next thing I'm going to do, down the left-hand side of this result here, this is called the index. I'm going to set the index to the date here. So we have a column called date, and I'm just going to set the index to that. I can type, having problems typing. Okay, and if I run that, you can see that I now have a data frame that has dates over here. This can be useful for a couple reasons. Why would I want to set the index for the date? Well, first of all, if you plot in pandas, generally it takes the date, it doesn't take the date, it takes the index and uses that as the x-axis here. So if I want to have dates along the x-axis, sticking that date in there can be useful. There are some other things you can do that are useful, like for time series analysis, you can resample the information or whatnot. I'm not really going to get into that too much here, but that is a possibility. Okay, so now what I'm going to do now is I'm just going to pull out the positive column, and I'm going to pull out the hospitalized column. And you see when I run that, I just have those two values there. And what I can do now at this point is I can say I want to do a plot of that. And if I do a plot of that, it thinks for a minute. And it should come back with a plot. Sorry, my computer's a little bit logged or thinking kind of hard because this broadcast here is using a lot of its juice, I guess. So you can see here we've got a little curve here. Here's the for March through April, and the blue line is the curve. It looks like it's sort of, for the past 2 weeks or so, been sort of straight. And this is a question that I'm trying to discover locally what's going on here. I've actually reached out to the local Utah coronavirus task force. They say that testing has gone down locally. You're not seeing that traditional upward exponential growth here. So it's not clear what's going on in Utah. The demand for testing has gone down, which seems kind of odd. Also, you'll see this little orange curve here. This is the hospitalization. Now note that they only started tracking this like a week or so ago. So it's got a bunch of missing numbers here. So if I wanted to just put in like zeros in there, I could say like fill NA and fill all those missing numbers with zeros. Another thing that I can do is just in general, this, if you're not familiar with pandas, I can put an interpolate in here, and this will just do a linear interpolation to sort of put those numbers so you can see sort of the growth of the hospitalized rates there. But and yeah, that probably that interpolates what it looks like. That's just doing a backwards fill because it didn't start with a number here. So maybe I'll do a fill NA instead, and that's probably slightly better. I mean, one thing I tell my students when they're doing data analysis is talk to a subject matter expert. I'm certainly not a subject matter expert in this. Like Noah said, we're not epidemiologists, we are data people. But there we go. This is basically the plot I've been shipping around that I haven't seen really people, at least at the local level here in Utah, make a plot like this. Now we could change the axis if we wanted to logarithmic axis. In this case, I'm not doing that right now because I think, at least in Utah, it's at the state where I like to see the growth this way. Once it starts getting bigger, it might make sense to shift it to a logarithmic axis there. Okay. Not seeing any other questions on my side. So that's what I wanted to show you is just that basic plot here. This is, you know, you could write this as one line of pandas here, but you know, I like to separate it out into their own lines just so I can walk through each line and say, okay, this line right here, this line is filtering by state, this line is setting the index, this line is pulling the 2 columns out, this line is filling in the missing numbers, and this line here is doing a plot. Now, watch how easy it is if I want to do another state like NC, is that North Carolina?
Mm-hmm.
You should be able to just put NC in there. And again, my computer is a little slow. Normally this would return pretty quickly, but I've got a bunch of stuff running on here. So here's the information for North Carolina. It doesn't look like North Carolina is tracking the hospitalization rate there, but there we go with North Carolina. Okay. So I will take this code here. I mean, that basically there's this 5 lines here, and you know, an import statement and 2 lines of code to read that. So about 7 lines of code to make this basic plot. You can go in and make it prettier and whatnot, but I think that shows you, you know, once you start mastering some of these tools, you can do things like this very quickly and gain a lot of insight and power into your data. And this is just sort of a stepping point. But I think that this, for me at least, this is giving me insight into what's happening locally and how the growth is looking as well. And it looks like North Carolina seems to be following sort of a similar take there. And it looks, you know, again, not an epidemiologist, but it looks like the social distancing might have caused things to not have such an exponential growth here, but it's more of a linear growth rather than exponential there.
Yeah, I think what you're showing here, what I think is a big takeaway for people that are beginning to do data science is that really it's approachable. Like, I mean, like you said, this is a few lines of code and not that much more difficult or strange than like Excel, right? And if you are asking for a quote on installing solar in your house, right? Or, hey, I'm going to buy a house. Can you look at the appraisal value, or, you know, something like this, you know, you're doing these kind of things anyway. So, you know, I think what you showed is to me something that every citizen of the United States should know how to do. And in fact, you should be double checking what the local leaders are telling you. And then hopefully when we get out of this, we also can start to ask some questions about, you know, there's some obvious holes in what's happening, and, you know, how different organizations have responded to the crisis. But, you know, like an informed citizen is really going to help make the best decisions in, you know, future elections. And that's why I think, even though this is a little, you know, again, everybody's got the chart. What they don't have is everybody can't do what Matt just did yet. But the way you explained it, I think is very clear, and I think it is a good way to set expectations. Is why shouldn't you be able to double check what the experts are telling you? Why don't you check what's on Fox News or CNN or Washington Post or New York Times? Like, let's check. Let's double check. Yeah. It's almost like you know, again, if you using the contractor analogy, would you just say, hey, I'm looking for someone to paint my house, and then just someone gives you a bid, you're like, great, I'll take it. Like, most people would not do that. Same thing with what the experts are telling you. Why not just double check, make sure that you understand what's happening, and have basic data science literacy.
Awesome. Yeah, and to your point, there isn't a lot of code here. Now, I understand that if you're new to this, like, the code here can be, even if you've just used Python but haven't used pandas, this can sort of make your eyes bug out because there's sort of a lot of syntax going on there. And so this takes time and practice to understand the syntax. Again, that's why people like Noah and I exist, because we teach people, we walk people through that. But it is something that is doable, and both Noah and I know that people can do this because we've taught thousands of people to do stuff like this. So it's not something that is only reserved for, superpowers or whatnot. And one of the nice things is that most states are releasing data, and so you have some data, right, and you can play around with this. Okay. Cool. Let's see, I've got a couple comments here. Nate says, I love how easy Jupyter Notebook is and let you check for yourself. Yeah, I think Jupyter is a great tool to leverage for doing exploratory stuff like this. Nate says also, I love how it took 2 seconds to do what Matt did for my state on my system and show 10 friends at work. Awesome. Good job, Nate. Yeah, I mean, I'm doing this as sort of, this is what's happening locally, but hopefully that's awesome to inspire other people to take action into their own hands as well. Okay, I think we're going to let Noah do some analysis here as well. So let's see if we can get Noah's screen shared, and we'll let him walk through some code unless he's got something else to talk about here.
Yeah. So the hopefully you can see my screen here. Yeah. So this link here, I put it into the chat, but basically the idea here is with what Matt had, you can check it into GitHub and you could look at his notebook inside of GitHub, and that's a great way to share data and share information. And what I did is I used the Collab notebook approach. I like Collab as a form of communication because someone can just click on this button, right? You could just click on this button and open it up. And that's what I did. I clicked on this and I have it exposed in this section here. And what I typically do on a project like this is I'll create these subheadings. If you notice this, and why I like that is that it creates a table of contents. So I can go to ingest, exploratory data analysis, modeling, and conclusion. And this is my advice about when you're doing data science. This is one of the requirements when I teach machine learning at Northwestern or Duke or one of the universities I teach at, is I require students to submit it in this format. And the reason why is that then you can separate your ideas and put them in different sections. So the ingestion phase is this, if you click on this section, and then you can see what some similar things to what Matt was doing, right? I can go through here and I can click on this and say, import pandas as PD, and then I read directly from that CSV file that's in GitHub. This approach is a really good approach to really, getting new information about a data set from some other source. And it's typically the way that I will go through and read things. And you can see here that it's got date, state. And then if you want to look at the last 5 rows, this is a typical thing I'll do at the beginning is I'll say df.tail, and then I'll look at the last 5 rows. And then just like Matt did, I also will look at the columns, right? So I'll say, what columns are available. And then another one in the ingestion phase that I do a lot is I'll do this df.shape. So I'll see, okay, so how many observations are there and how many columns? So we can see that there's 2,105 observations, and then there's 5 columns. And then now I can get into the EDA phase. So what I may do is actually just close this. So then it sits there and kind of hides away. And then I get into the EDA phase. And this is where I start to get into like more, not saying I know what the answer is. And again, if we look at the pros and cons of pundits on TV and politicians, a lot of them are really confident. And that's the opposite trait that you need for data science. You want to be really humble and say, I don't know anything. Let me just start asking questions. So in this case, I could say a describe, right? And I can see that the percentile of the median state in this particular data set has 1 death, and but the max is 7,000. And now if we look at the cases and deaths in the US, I could do a seaborne plot, and I say import seaborne as SNS. And the way this works is that they have several kinds of plots, just like they do in Excel, like a bar plot, a chart, scatter plot. In this case, I pick scatter plot. And then I just make an X variable here, which is the cases, and a Y variable, the deaths. And one of the things that's kind of neat about Seaborn is you can see here, I can make the hue a different color, right? So basically this starts to show me maybe, you can play around with this and do different things, but I can see obviously that, this particular instance has there's a lot of deaths associated with this is New York. And then also I could change things and make the size different. It doesn't add a ton of value to this particular plot, but as you get into more variables, you can play around with hue and size, and those are you'll do this in R as well. Like a lot of people will play around with those to just maybe share a different story that you want to share. And notice that I did the data, I passed it in right there. So
Awesome.
yeah,
Can I just jump in here
yeah.
Riff on this a little bit? So I love Seaborn and I use it a lot too. I love what Noah's doing here with taking the scatter plot. One of the nice things about Seaborn is that typically a scatter plot shows 2 dimensions of data, an X and a Y, and being able to throw in hue and size actually gives you 3 and 4 dimensions. And so this is a great way for people who aren't good at grokking 3-dimensional plots. I think most people in general aren't good at grokking 3 or 4-dimensional plots to sort of get a few more bits of dimensionality into your data and see if there's some other relationships in there. So if you haven't checked out Seaborn, really good library, integrates really well with pandas as well, because basically it works off of pandas data frames.
Yeah, it's a good point. With if you do get into unsupervised machine learning in the EDA phase, which is actually a great use case for unsupervised machine learning, a lot of times I think if you're new to data science, you hear machine learning and it's like very spooky. It's like, oh, machine learning, but there's actually a couple easy ways to split it up. One is the predictive part of it, which is, hey, how many deaths are going to happen in a state? And then there's the part that I'm a little more interested in is the discovery part, which is like, I have no idea what's happening. I'm going to take some variables and I'm going to cluster them together. That's unsupervised machine learning. And it's going to tell me something that I don't know. It'll discover some hidden feature. And that a lot of times those hidden features, like, whatever it is, they can actually work really well in this multidimensional plot.
Yeah.
So the date-based EDA, like Matt was mentioning, is also an interesting way to deal with this. So in this case, I assign this date column here. I set the index, and you can see here that I've got these different date index. And what that does is that it allows me to do like more like human level filtering. And so if I wanted to look at, for example, again, in more of like a common sense format, what is today, what is 2 days ago, you can see that today is 410, right? It's and then 2 days ago is 408, right? And I can assign those variables into more like things that are common human language, right? And then from here, I can then even do filters, and I can filter by the different date ranges. So I can say, okay, what about I want to look at all of the information that I have available from the day before to today, right? And I can see here that I've got that, and I can look at the first few observations. So then what do I do with that? Well, one of the things you could do is if you want to look at the recent distribution, what a distribution does is show you the pattern, right? So how many deaths, for example, what is the shape of the deaths in the United States? And you can see that, in fact, this is not a normal distribution, right? Most things have a normal distribution, like height, weight, things like that, because the population, there's only so many, 7'2" people, and there's only so many 4' people. But in this case, you can see that this is not a normal distribution. This is massively skewed up here, or at least initially this is not a normal distribution. It's got some weird things going on because New York is so much larger than everyone else. So it does tell us something, right? It tells us that, I'm just guessing here, but maybe that some of this is going to play out in other states, right? Because we know that this is the extreme, but that's one of the things that you could maybe look at when you look at a distribution of the data. Another thing that I do here as well is sort the data frame by a couple different values. So, if I wanted to sort first by deaths, and then the second case here would be the cases. I could kind of sort things through and then change it to ascending. And you can toggle this if you want to go either way. So you can see, on 449 that the deaths in New York were 7,067, and then in 408 the deaths were 6,000. So you can see that's a pretty dramatic change, and we can see that if I look at the top 10, the states are basically, really the leaders here are Louisiana, Michigan, New York, and New York, right? These are really, and California is right behind here. So what could you do with that? Again, I could do a shape operation. In this case, there's more than 50 because the states are actually leading both days that are in this date range. But one of the things that I would probably do is kind of look into a state-based analysis. And you can see here, I can just kind of grab this off and kind of grab these states here. And then what I can do is I can drop a column maybe that I don't need, and then verify that those states are the same. So we can see that, in this case, because the same states show up 2 days in a row, that I've got only 5 states. But one of the things I'm going to do here is do a faceted plot with Seaborn. And so with Seaborn, just like they have the scatter plot, you also can do a column, add a column here. And what it'll do is it'll create these different plots of different states, right? Because I say the column should be the state. I had these 5 states here, 1, 2, 3, 4, 5, 6 states. So you can see what's fun about the faceted plots is it lets you compare, a cohort, right? So I can look at this and say, okay, look, here's all the top states that have high death rates. We got Illinois, California, New York, New Jersey, and you can maybe start looking into the future and going, well, this is obviously not good, right? This is very bad. But then, of these other states, will they become New York, for example? Like,
Yeah.
I don't know if you had any ideas on that.
Yeah, and no, I think that's really great. I think one of the things that, at least my personal take on it, is that I think Utah is sort of lagging behind some of these other states, and so I think it's crucial to be aware of what's going on and understand, these are situations that could play out, like you said, and using something like this, doing fasting and pulling apart things that are overlapping, lets you sort of tease them apart and look into them and compare them a little bit easier. And it's also adding another dimension to your plots as well. So that's awesome. Thanks for sharing that.
And then if you go through here and look at you can also look at different date ranges as well. So this is where you could play around with this, and maybe actually go back further in time and go from 308, which is really when things started to get bad, and actually do an interactive plot with Plotly. So Plotly is another library that's kind of interesting because it's only a few lines of code to do a scatter plot, and I also can do facets here. And what happens is that now I can actually explore the data on every single observation. So I can go here and look at every single day, and you can see that I can actually hover over it, and it'll tell me what's going on. So if I wanted to do more and more stuff to this plot inside of that hover, I could have all kinds of interesting information, like maybe hospitalization or, party affiliation or whatever it is. But it is, you can see here in this plot that they're definitely New Jersey and New York. There's some stuff going down there that is not good, right? I mean, this is really, an exponential plot. And then you can see other states where we don't know yet, right? Like there are some, California has definitely flattened the curve, but what we don't know is, what will it look like out here? Like, will it be up here or will it be down there? So Plotly, in my opinion, works pretty well with something like Collab, and it's a great thing to look at. Now, that was just kind of playing around with the data a little bit, but what I like to look at is actually like any kind of a strange variable that I can to, just try ideas out. Not saying I know what the answer is, but say I don't know what the answer is. So what can I do? Well, one of the things that I've been looking at, because I have my bachelor's degree is nutritional science. So I do have some medical training, like not a lot, but I have some. I have a bachelor's degree, and sugar intake in particular uh, is actually a very interesting health metric. And I've been looking at this for the last several years, give a talk on this at Strata, and you can see that certain states have higher sugar intakes than others. So
Mm.
just as a question, we know that sugar is actually a toxin, and it actually causes many diseases like pre-diabetes. It causes obesity, the kidney problems, all kinds of problems with this, heart disease. So could this play a factor, right? So one of the things that I can do is take that, and then I also can look at combining that. So I go to the merge, right? So this would be what a data scientist or an epidemiologist would do, is start to merge these data sets. I just say df.merge, and I merge on the state. And then the next thing is, okay, well, let's take some political data, right? So, I think that everyone's got to have a bias, right? Whatever political leaning you are, is what the other side's the bad side. So if you look at this, though, you can see that I can add the winning party for the 2016 election, Republicans, Democrats, to the data set, and then I can actually merge this together. And now I've got actually really interesting data that I've combined with this. So I have the COVID data, I have the sugar data, which shows us health information. Then I have the political affiliation. And could we potentially create an unsupervised machine learning model that uses all this, right? Because each of them they all say something that's very, very different. So one of the things that you could do before you create a machine learning model is to create a heat map. So in this case, to prepare for it, I do correlation. So on the data frame, I just say .core, and what we can see here, just numerically, obviously cases and deaths are almost one, right? Because they're highly correlated. That's intuitive. And then there's some things that are not as intuitive, especially if you're reading a lot of news, is you would think, oh, Democratic states, they're wealthy, they have lots of education. Well, they're actually currently positively correlated with deaths, and at this exact point in time, we don't know what the future will hold, but and then Republicans are actually negatively correlated with deaths. So that's one thing that's interesting. And another thing that's surprising to me as well, and again, we don't know right now, in the future it may be different, is that sugar intake is also negatively correlated. So this variable, maybe it doesn't do anything, right? And that's also okay to have an idea, and then it doesn't pan out currently. And so what I do is I use this Plotly graph here, and I can hover over, and I can actually look at these features. And in this case, I can see, again, if I look at deaths here and I look at Democrats, it's actually correlated to Democratic leaning states. Now, again, we don't know what will happen in the future. It looks like COVID-19 came in from places that have highly dense urban areas, which are often correlated with Democratic leaning voters. But it's just more of this is the way I approach data science, is instead of pretending I know all the answers, just I don't know anything. What can I learn about something and discover things, and then just kind of try out ideas. So this, kind of to wrap this up, this I think is a decent starter kit to play around with yourself, like use this and come up with your own ideas. Like maybe you could add real estate data, or maybe there's something that would be interesting to add, maybe sentiment analysis with news in your state, or whatever.
Yeah.
So that's basically what I got to share.
Awesome. Yeah, thanks for sharing that. That's a really cool notebook. I like the layout of it. I like the sections. That's also something that I teach when I'm doing, at my courses or whatnot, is very important for someone who's doing, quote, data science, to be a good communicator. Also for a developer in general, right? It doesn't do much good to have someone who can sit in a cubicle and just crank out code if they can't communicate and work well with others or explain what's going on, especially for someone who's doing, quote, data science. if you can't communicate your models or why your models are important, you're not going to bring much value to the company. Thanks for sharing that. I mean, some thoughts that went through my mind, Noah, as you were going over that were just, is New York an outlier at this point? It probably is an outlier, right? And so if we remove New York from the data set, what happens to those correlations? Do those change or whatnot? And we see different correlations pop up. Very interesting. Cool. Let's see if we've got any questions here. Let's see, Riyadh says, perhaps you could impute that if other states follow New York's process, they will have that number of deaths. Yeah, I mean, you could basically model other things and say that, if you were to follow New York, this is what would happen. A lot of people are somewhat weary of doing that. I mean, one thing to just, again, not an epidemiologist here, you can do curve fitting to curve fit New York's rates. One thing to be aware of is just, with an exponential curve like this, if you have something that's doubling every 2 to 3 days, but you delay that doubling, right? If you delay that doubling for a week, that has huge impact into what happens with those growth rates. So just be aware of that, and also be aware that if you do model something and you put it publicly, be ready for people to sort of attack it. Seems like that's what a lot of technical people like to do, is nitpick and find things that are wrong with it. So just take that with a grain of salt if you're going to be public on the internet. Get your hard hat on.
Well, yeah, and I think that's why I like personally staying with I like EDA more than I like prediction, because with EDA you're
Safer,
basically well, it's like I'm just telling you what I found out. I'm not telling you what it means. I'm just telling you this is what I've seen. This is what looks like it's happening. What do you think it is? And it's I think it's a great mindset. We're in an age where, I mean, people very confidently at the highest levels of every news, government are really confident. They're like, oh well, this is exactly what's going to happen, and it's just dead wrong. And in fact, really irresponsible. And I think it's good to say, in general with data science, that's one big takeaway is if you're confident, you should be very worried. And I'm the same way with software. Almost one of the best techniques I do to debug things is, and I don't really do it as much anymore because I'm not working as part of a software team, but when I was debugging something, I would always focus first on humans. So I would kind of go, hey, what do you think's going on? And, kind of ask people about stuff even before looking at things. And then I would ask someone, what do you think's happening? And then if I ever heard someone say, well, the API backend, it's definitely not that. That's the first thing I would look at is like whenever someone's really confident, that's like one of the best signals that when they say, oh, it's definitely not that system for sure. That was like, thank you. Now I know exactly where to look. And 80% of the time, that's where the problem was. So for me, confidence means that it's a great signal that's opposite of what the person intends it to be.
Yeah, and in general, with a lot of data science stuff, I mean, just a couple ideas on what you said, Noah. In general, if you have a predictive model that performs very well, that's an indication that you're either leaking data, or you're cheating, or you're not, doing cross-validation correctly. In general, right? Because most models that perform very well are either cheating or they're very simple models. Otherwise, they don't generally perform super well. And then another idea that I had while you're talking is just the importance of exploratory data analysis. I think we're on the same page there. Like my Stanford course is basically an exploratory data analysis course where rather than saying necessarily we're going to make predictions about it, we're going into a data set and saying, let's see what the data tells us. What is in the data? What can we infer from that? What questions, what things can we dig into that? And I think there's a lot of power with exploratory data analysis that a lot of people they don't think it's sexy enough or don't want to invest the time in it. But if you do good exploratory data analysis, especially if you're a subject matter expert or have access to one, you will have really good insight into your data and really start understanding how your product's being used, how people are interacting with your software, your systems. It can be super powerful. Okay. Other questions on your end, Noah? Do you have any questions? I think we don't have any more questions on my end here.
Yeah, it seems like maybe a good place to wrap up. We got some great stuff that we shared and great questions. And if everybody likes this, maybe it's something we do on a weekly basis.
Yeah, definitely. So let's wrap up then with our thoughts of the week or takeaways or pointers. So my thought here would be, it. I think both Noah and I've shared something very simple. Noah's gone into a little bit more depth, but I would say one of the ways, if you want to learn this, a really good way to learn it is to try something out. And both Noah and I have shared pretty simple, easy to get going software here. So if you're like of the mindset that this is too hard or I can't do this, I would say my takeaway is an invitation for you to try this out and see if you can run it on your own, especially like with my code, see if you can run it with your own state. It's 10 lines of code. There's a huge power that comes from listening to someone talk about something to doing it yourself. And that's very empowering and can lead you down a path to discovering a lot of super powerful tools and functionality that you can leverage.
Yeah, I see the same. I can't do Brazilian Jiu-Jitsu anymore for a while because until we get out of this. But one of the reasons I liked Brazilian Jiu-Jitsu is that it's got the same thing as programming, the same kind of a learning process where you can't just go to YouTube, watch some technique, and then never practice it and expect that it's going to work, right? That's just not how it works. You have to actually try the technique that you learn, and the process of you failing, that's how you learn. That's how your body learns it. Your body will then just start to understand how to do some martial arts technique. Programming is very, very similar. Like the more, one of the things I will say to students is that life always works for the most part, right? You get in your car, you drive to the store, it works. You turn on the faucet, it works. Programming, it's the opposite of that. It's always broken. And if you can get under the mindset that like everything's always broken and that means that you're learning something. So the more it's broken, the more things don't work, you should be excited about that because that means you're learning something. If in the passive sense that you described, which is, hey, I watched this thing, I understand it, that's actually very dangerous. It's better to be trying it and breaking things don't work, I don't understand, and actually being happy. Like you should be happy when you're programming and nothing works. That means you're actually learning something. If it all works, that means you're not understanding it.
Yeah, awesome. Cool. Let's see here. Okay, so we just got to appreciate the walkthrough. Yeah, awesome. Yeah, again, to Noah's point, if you like this, let us know, like this, share it with others if you have ideas or things you want to talk about or whatnot. I think both of us are open to that as well. So thanks, Noah. It's been a pleasure sharing with you, and we'll hopefully do this again soon.
Sounds good. All right. See you later, everybody.
Okay, bye.